Hello, I am Munir Haq and welcome to my Android app development tutorial. Today our topic is Android LiveData. We will learn how to use Android LiveData to update UI data inside Fragment or activity from ViewModel. So what is LiveData in the first place? LiveData is an Android architecture component which fundamentally has two attributes: Observable Data Holder. LiveData holds data as a wrapper that holds any data. LiveData is an observable that being observed by the fragment, which means when the data inside the LiveData changes, the fragment gets notified and UI get refreshed automatically. And LiveData is lifecycle aware, which means LiveData knows the state of our fragment, whether it is in the background or foreground. If the view is in background, LiveData automatically stops updating the view, so we do not need to manually configure the observing operations. Combining these two powerful properties, we can say LiveData does right things in right time. So why we use LiveData? Well, to get the answer, we need to go backward a little on our previous tutorial where we applied ViewModel in our project. Let's see how our project look like in the current state. So the last time our app looks like this, and we can press any value here, and if I rotate the phone, the value is not changed and the word is not changed and the score is not changed as well. So it is totally understandable, but we have some inefficiency in our code. When we go back to our code in our fragment puzzle, we can see some ambiguous call of update score and update word, and these calls are frequently calling inside our button OK and button skip. And when we go to the button OK and button skip and puzzle view model, we can also see some here everything is next word, next word, next word. Now this is an issue, definitely an issue, because the next word, all this next word and this functionality, this update score and update word is totally dedicated to create new words and new scores. So what if I can do this? We can do this in a single class, and that single class, if the single class magically update our view model data into our fragment puzzle, it would be a prettier and nicer. So here comes the LiveData. LiveData wraps around the UI data and update in our fragment automatically. Right now what happens, our puzzle fragment has a direct reference to the puzzle view model, but view model, in our case puzzle view model, has no clue which views are using the view model. We need something to notify any data changes to view and automatically update the UI. We can do this thing using LiveData. LiveData works as an observable wrapper and also lifecycle aware, as I said earlier. LiveData automatically does the right things at the right time and saves us from many lifecycle related potential bugs and memory leaks. So enough talk, let's see how to implement and use LiveData in our actual code. To use the feature of LiveData, we need to first declare our variable as LiveData, and here these two variable score and word, these two things we will wrap inside our LiveData and use it in our fragment puzzle to update the UI. So first we will wrap this score and word in LiveData. To use to wrap any object or data to object or any type into LiveData, we have two different ways. One is using LiveData class and another is using mutual LiveData class. So we are using mutable LiveData class here. So it will be like this. We will make it as val, and it will be like mutable live data, and the type will be integer, as score is integer as always. And what these things means, actually we are wrapping an integer inside wrapping an integer variable named score inside mutable live data, and it is val, and we declared this thing val for a reason, because we are defining the mutable live data itself, not the integer. And mutable live data, it is the wrapper, it will not change. Only the object or data type inside the mutable live data, in our case integer, it will change, not the mutable live data will be changed. So we declare it as val. And we do the same thing with words, and it will be mutable live data, like this. So one thing to remember, when we declare any mutable live data or live data, it will at the first time it will be initialized as null. So to handle the exception, we will give the value of a score as null, score as 0. So score is 0. It will not definitely work, because the score is a mutable live data itself, not the integer. So we will put a value, so value is 0. We will not do the same thing with load with words, because inside init we will have the load data, and the load data will load up some word puzzle object. So we do not need to make it as null. Okay, and we see some code broke here, because it says word, so it will be word dot value, as it is a mutable live data, so it will be word dot value. And a score is not working, so it will be score dot value. And as I just said, that all mutable live data or live data starts with null, so it could be null, so we make it like make it nullable. So, and again it's not working. Okay, we need to use the plus method, so it will be dot, or it will be minus, as it is skip, so it will be minus 1, and keep this here. So we just copy paste these two lines to here, and it is plus, so we will copy paste here, but we, instead of using minus, we will use plus. So inside our view model, we declared score and word as mutable live data, and also handles the null exception here, and we access our mutable live data using a value property. Our next task is to observe these two live data variable from our fragment puzzle. So before declaring or using this observable data, we need to first bind our lifecycle owner. So in this case, our lifecycle owner is this class. So we will use use here, okay, under this line, below this line, so we'll use binding dot lifecycle owner. In our case, this fragment will be the lifecycle owner, okay. And we will use the observer, so we will use the puzzle view model, which is this object of this puzzle view model class dot word. What is this mutable live data or live data, and we will observe this. So observe, there is a function name observe, and observe takes two parameter. One is the lifecycle owner, so view lifecycle owner, so it's the view lifecycle owner, and another is a lambda function which will be a observer, and inside this observer we will define what we will do with this word. So in our case, we update word, we will just copy paste this thing, this two line, so just copy here and paste it here inside the observer, and we see a little issue here, that word dot unresolved reference question gap 1, okay. So it will be word dot value, because we are, it is a this word is a mutable live data, so we need to use value property. So word dot value dot question gap 1, okay. We will do the same thing here, dot value, okay. We will do the same thing for our score, so it will be puzzle view model dot score dot observe, and it will be view lifecycle owner, and it will be observer, and we will just copy paste and go to the here and copy this line and copy this line here, paste this line here. So here we see the score, and we can see it is the it, we see the it, so we use the it, so it will be it, and it may be not null, so it not null and toString. So why it? Because it is the observer, it is showing the it, and this it is referred to the, and it is integer, and this referred to the our score, okay. So we still have some errors in our code, so we go through. We do not need this update word or update score anymore, and okay, it will be word dot value, okay. And in the game over function, inside the game over function, we can see the puzzle view model dot score, so it will be dot puzzle view model, sorry, dot score dot value. So as we already know that when a live data or mutable live data always starts from null, so we need to check the null condition here, and we want to do a little if else version, like if this total value is null, then replace it with 0, and if this is not null, just use this value. So we will not expressively use if else condition here, rather we will use Kotlin's Elvis operator. So it will be like this is the shortcut of the if else statement. So it means if this value is null, use 0, and else if this value is not null, use this value itself. Okay, now we go to this thing. We do not need this update score and update word anymore, because we have our observer and live data. So let's see what happen if we run our project. Checking our app and play, and we can see our words, and even the score is updating and the word is updating. All updates are coming through the live data, which works as an observer. This is the live data we declared, and this is the live data observer. This is the live data observer working on our UI. So this is an excellent thing, because we do not need any lifecycle word, or we do not concern about the lifecycle and previously ambiguous update word and update score function. So all things we just declared here and declared the observer here, and we forgot everything about lifecycle, live data itself updating data for ourselves. So this is an excellent thing, but we are not finished yet. We have a remaining task, which is we need to enable our game over function here. We will take help from live data, as we can see the score is updating through the live data and the word is updating through the live data. So we can easily handle this event. Then when word is empty, we will enable the game over. So first we will declare a live data object, another live data object. So name will be val game finish, and it will be mutable live data of boolean type, and it will be, and we will first declare it as a false value. So it will be value will be false. Okay, and when the vars is empty, vars will be empty, we will simply make it as true and make a signal that our game is finished. So it will be game finish dot value, it will be true. Okay, now go back to our fragment puzzle and make an observer for this live data object. So it will be like same thing like word and score. So puzzle ViewModel dot game finish dot observe, and it will be view lifecycle owner, and it will be observer, and as we can see, eat the boolean. So eat, so we will place the if eat. That means if the game finish is true, we will simply call the game over function, otherwise not. Okay, Okay, now one thing for this time being only, we will not navigate to our score fragment. So we will just show a toast message instead. So we will show toast dot make text, and it will be say game finished, and length short and show. So we will show this toast message first, and for test purpose, and if this works fine, we will just go back to our switching to our score fragment here, game over fragment. Okay, so if we run our app again, checking our app, and we press here and simply just press OK, and showing that game finished. So it's our game over fragment is working fine, and but I think there is a problem. When we rotate our phone, the game finish is again called, and when we rotate our phone, the game finished is again called, but it is not a expected behavior, because we are using the ViewModel, and we already know that ViewModel survives the runtime configuration changes. Why this happens? Because actually this happens because of the nature or the property of LiveData. We already know that the LiveData always provide the latest data to the user UI controller like Fragment. So if I open the image for you, and here we can see the LiveData always provides the latest data to our activity or fragment. Here when the game is finished, so it is true, and when we just rotate our phone, we always got the true value here, and the game over is invoked. How can I read of it? This is a little tricky thing. We can just create another function here, and like fun on game over, and inside this function we will make this game value to false, just to tell our project that our game is already finished, and it will set it to false. And inside our fragment puzzle, inside the game over, we will just call the puzzle ViewModel dot on game over, or just on game over. Okay, now when we run here, checking our app once again, and here play, press OK, and now it's showing that game finished. And when I rotate the phone, no game finisher whatsoever toast is shown, because when we create when we call this inside our game over, that when you call this inside our game over, and it simply set this thing to false. Now we will simply comment out our toast and write our real application. Okay, I think there is a little problem, little mistake here. So we call it inside a check answer. We call it we called puzzle view model dot next word. Actually, this is not necessary because the next word, the game finish is already checking for word is already going on through the view model through the live data, so we do not need this line, and also we delete this line, and now we run our app, and from our app you can see that you just press OK, and after finishing our list we simply go to our score fragment or game over fragment, and our live data is working fine. In this tutorial we learned about live data and the basic uses and implementation of live data, and throughout the project we will also use live data in some upcoming tutorials, and this is the very basic or foundation of live data. And hopefully you enjoyed the video. Please give a like if you like the video and subscribe if you haven't subscribed yet. Signing off today. Good night.